Okay, this is day 9 of the distance learning packet math section, and we're starting off with a task about coffee, and that's 8th grade expressions and equations. All right, so we have some information about this coffee. It is $18.96 for 3 pounds, and then we have some questions to answer. That's all we have. So A is, what is the cost per pound? So this is going to be the unit rate. If we're thinking about a graph, it's going to be the slope. So we have to find the rate. So cost per pound. So use the words as a guide. Cost, that'll tell you what to put on the top of our fraction and what to put on the bottom. So cost per pound. So do we have enough information? So the cost is $18.96 per 3 pounds of coffee. So that is division, so we need to divide. $18.96 divided by 3. So 3 goes into 18. 6, bring your decimal up. 0, bring down the 9. That's 3. That's 9. 0, bring down the 6. So that's 2. So this would be $6.32 per pound. Okay. B asks, how many pounds of coffee could she buy for $1? How many pounds could she buy for $1? So could she buy an entire pound? No. About 1/6 of a pound, right? So let's see if we can figure this out exactly. I'm going to go back to 7th grade proportions and use a proportion equation to do this. So we have this information. Actually, let's use what we just calculated. A little bit smaller number. So this would be 6.32 per 1 pound. So keep in mind this is dollars over pounds. So we want to know how many pounds. So this is our unknown here, x. That's a 1. And then for $1. Okay, so this is a proportion equations. Remember how we solve these? Cross multiply. So I'm going to write this out as 6.32 and then times x. 6.32x equals, and then 1 times 1, which is 1. Okay, and then we can just divide both sides by 6.32. It's the same as solving an equation, just that we have decimals this time. Okay, so if we do that, we get x equals, so 1, so you can use a calculator for this, 1 divided by 6.32, and that would be 0. Since it's dollars, we're going to round it to the hundreds place, 1/6. Oh, we're talking about pounds. So that's fine. Let's just round it to the hundreds place anyway. 0.16 pounds. So not very much. It's not a very practical problem, because typically you would figure out how many pounds you want, and then you would be told how much that costs. So she couldn't buy a whole pound. So she could buy, maybe 1/4 of a pound if she didn't have enough money, but 1/4 of a pound would still cost more than $1. But I highly doubt anybody's going to actually measure out 0.16 pounds, but it's possible. All right, and then graph the relationship in cost. So we have decimals. It's not going to be a perfect graph. On the x-axis, we have the pounds, and the y, we have the cost. So the y needs to go up to at least, $18.96. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes, 15 lines. So we're going to have to count by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and on the x-axis, really only goes up 3 pounds of coffee. And then if we want to try to squeeze in that answer for part B, we're going to need to space this out. So I'm going to do 1, 2, 3, 4 boxes is 1. 1, 2, 3, 4 boxes again. So it'll be 2, 1, 2, 3, 4. So that way we have 0.5, 0.25, 0.75 of each of those pounds. Okay, so let's graph. So the first information that we were given was 3 pounds is almost $19. So halfway between 18 and 19. So take the 3, follow it up, and that point is right about there. And then we figured out that 1 pound is about 632, so that's somewhere right in here. Okay, and then if we were to graph that 0 pounds is $0, so we can come out from the origin and we can draw a straight line using a ruler, of course. I mean, I can do this digitally, and it makes a straight line, but you would use a ruler or the edge of your notebook, whatever you have that's a straight line, straight edge. Okay, so let's see if we can find the answer for B. So we wanted to know for $1. $1. So if we look on our y-axis, we have $1 halfway between the 0 and the 2. And then we follow it over to the line. I'm going to do that in a different color. So that would be about here, right? And then we follow that down. So what is that number? So this was 0.25. So yeah, it's definitely less than 0.25, isn't it? It's almost about halfway. So based off of the graph, I would guess it's 0.12 or so, which is close. So yeah, we could have used a graph instead of proportion equation, but of course the proportion equation is more accurate. All right, and the last part. What is the meaning of the slope? Okay, the meaning of the slope is our rate, and that is what they asked in the first question. What is the cost per pound? So the slope represents the cost per pound for the coffee. Okay, and that's it. All right. Another rule of 4. Same deal. I'll help you with the slope, the y-intercept, and the equation. Looking at the graph, I immediately see the y-intercept is 3. We're just looking for the place where the line crosses the y-axis. That's 3. And then the slope, we're going to use rise over run. So slope is rise over run. And this time we have 2 points given. So let's see if we can figure this out. Okay, here's my rise. Here's my run. So the rise, we're going to go down. So that's going to be a negative. So from 3 to 0, that's negative 3. And then our run is 0 to 2, so that's 2. So negative 3 over 2. Negative 3 over 2. All right, putting that into our equation, y equals mx plus b. Y equals m is negative 3 over 2. Then our x, and then slope is positive 3. The y-intercept is positive 3. All right. And then the table. So it's kind of like we did the previous day. Just look at our graph. We have 2 points given. Here's another point where the line crosses the grid exactly. So there's 3 points right there. We have 0, 3. We have 2, 0. And we have 4, negative 3. So that's it. Put those 3 points on your table and you're done. Okay, qualitative graphs. Okay, so these are the ones that are not linear, but they are descriptive. They tell us information about what's going on. Okay, so I'll do an example from each. I'll do this first box. So it says, the graph below displays the distance Brian was from home as he ran in preparation for a marathon. describe the change in distance over time. Okay, so each time the slope changes, we need to talk about that. So what is going on between all those points? So this is distance from home and time. We don't have numbers. We don't really need them. So it starts off at 0, 0, which means he's at home. So Brian started running. Since the slope is kind of flat, so slowly, you could probably even say jogging or even walking. Started running slowly from his house. Then the steep changed very quickly, and it's fairly steep. So then ran quickly. Okay, so that's this part. So he started running slowly from his house, then ran quickly, then slowed down, and finally. So the slope is going down now. So that's not the speed. He's not running slower because it's going down. He turned around and he's running back towards his house. So once he gets back to this point, he's at home again. So and finally turned around and ran home. And the slope is pretty steep, so I'm going to say quickly. Okay, so he started off running slowly from his house. Okay, slowly, and then he sped up, and then he kind of slowed down again, and then he turned around and he ran back towards his house. Okay, so we had to say 4 different things because the line changes direction 4 times. All right, so I'll leave the next one up to you, and then the bottom 2 we have to sketch our own graph. So let's take a look at this last one. All right, so it says a well is being dug on a piece of land. The team digs at a constant rate, takes a break for lunch, then continues digging, another human error, digging at a slower constant rate. Sketch a graph, a qualitative graph, that shows the depth of the well over time. So we need that information. So time, and then this is depth, the y-axis. It's kind of weird to think of it as a positive number, but it's fine. So we're just talking about how deep. So a foot deep is going to be a positive 1. So a foot deep. All right, so let's see what happens. They start, so 0 depth, which would be this point, would be at ground level, right? So that's where they start. So digs at a constant rate. So we're just going to draw straight line. Constant rate means straight line. I don't know how quickly. It doesn't say. It just says constant rate. Takes a break for lunch. So while they're eating lunch, does the hole get deeper? No. It just stays for some time. So maybe, half hour for their lunch. And then continues digging at a slower constant rate. So slower than the first rate. So that means our line has to be a little bit less steep. Okay, I'm actually going to exaggerate this a little bit more so it's easier to see. So I'm going to go fairly steep, and then a lunch break, and then slower constant rate. And then that's all we know. It doesn't say how long, it doesn't say anything. So I guess we can assume that once we get to this point, okay, so that's whatever depth we needed the hole to be, and then we can see how much time it took if we had numbers. Okay, so that's it. All right, and then the last part, another equation to solve. I was going to rewrite it. 50 plus 30z equals 250 plus 10z. So this time we have the variable on both sides. So we have a lot of options as to how we can start. And again, it doesn't matter. You will get the same answer. So you do not have to do it exactly how I do it. So I am going to subtract 10z first. And I'm lining it up under the z terms, not under the numbers. Okay, so what happens here then? 10z minus 10z, so that becomes a 0. So that's what we want. So now we have only one term on the right side, and it's a number. Okay, and then I look on the left, we have 30z minus 10z, so that gives us 20z, and then it's positive, and then we have this 50 still here. Okay, now we have the variable on the left. So I want to get rid of all the other numbers around it. Let's subtract the 50. So that makes a 0. Subtract the 50 on the right. And that leaves us with 20z on the left equals 200 on the right side. Then our final step, divide by 20 on both sides. And that will give us z equals 200 divided by 20. Okay, those cancel, we get 10. Okay, we can check our work. So we want to make sure that this is a true statement. So is this really equal when we put a 10 for z? So just doing this in our heads, 50 plus 300, so that's 30 times 10. Does that equal, so that would be 350. So does that equal 250 plus 100? It sure does. Okay, so that's you could actually put this right here, because that's how you know. I checked my work, right? I substituted the 10 back into the original equation, and both sides are equal, so that's how I know my answer is correct. And that is the end of day 9.